Good afternoon, everyone. Today we will have again a lecture on steel structures. So already in last lectures we have seen the basics regarding steel structures. We have gone through the syllabus of steel structures. We have gone through the scheme. What are the different as per that is university schemes? What are the evaluation schemes we have seen? How much internal and external marks to be taken care in steel structures we have seen, and also in a short briefly we have gone through the different units. Totally in steel structures there are 4 units, so we have gone through all the 4 units in short. Again, in today's lectures we will have some more concepts regarding steel structures, or actually we will start the unit number 1. So basically, unit number 1 deals with the different types of steel sections. What are the grades of steel sections? What are the different shapes of steel sections? What are the advantages or disadvantages of steel sections? And we will also go through the some basics regarding the IS codes also. Okay, so IS 800 2007. What are the different things considered in IS codes? We will see in short the different concerns regarding the IS codes also. So we will start the today's lectures regarding with the steel structures. So what is the steel structures, or what are the steel structures? So in steel structures, structural steel is the main that is load carrying material to transfer the load within them and to transfer load to the ground. Because in already we have seen in the RCC structures, the load it has been transferred from slab to beams, beams to columns, and columns to foundations. The same way the loads calculations or the transfer of loads it has been taken care in steel structures. So while transferring the load will be transferred from top to bottoms. That means it has been taken by the loads will be transferred to the beams to the columns, and finally it has been transferred from columns to the ground. That is nothing but the foundations. The same way the load will be transferred in the steel structures also. Okay. So while transferring the load, what are the different sections? So there are the different sections. That is the I beams. It has been taken. It has been in the shape of I. That is I beams, T sections, that is channel sections or C sections, or steel plates are also used. Steel plates is normally the slab material. It has been used, or the slab that is on the beams. Steel plates. It has been above the beams. Steel plates is also used. Those steel sections is also made. It is having some proper thicknesses there. Steel plates is having a proper thickness. Again, steel, concrete, composite structures are also used in high-rise buildings, but we are only going to study about the steel structures in this paper, because in composite structures, in some part it has been made in RCC and some part it has been made in the steels. But basically, in this steel structure subject, we will we will take care of about the steel structures. But in nowadays, most of the constructions RCC structures are also used, and some part of that RCC structures it has been laid down with the help of the steels also. Okay. Or we can have the totally steel structures also. Next is nothing but the common steels, that is the structures, roof truss in factories, that is cinema halls, railway stations, or railway bridge, or foot over bridges also, or railway bridges also. So these are made up of steel structures. Crane girders you have already seen in nowadays in constructions of these flyovers. When we are transferring the heavy materials or heavy equipments from one place to another place, so that cranes are required. Okay? That crane girders are required. So that crane girders it has been it has been established with the help of the steel structures. So crane girders are also it has been made up of the steel structures. Again, the columns beams are made up of steel, that is I sections or sections or channel sections. So these are made up of steels. So crane girders, columns or beams, it has been made up of steel. Again, third point it is nothing but the plate girders. Bridges are also made, different bridges over the rivers, bridges over the canals. So it has been made with the help of the steel. Again, plate girders are also used in order to transfer the loads from the individual members to the ground. The plate girders are also used. Okay. Again, fourth is nothing but the transmission towers, electrical transmission towers. You have already seen the transmission towers. So transmission towers in which it has been made with the help of angle sections. Okay, so transmission towers or water tanks. Water tanks nowadays previous you have already seen in RCC water tanks, but nowadays it has been used. Steel water tanks are also used. Okay, so water tanks are also used. So transmission towers, water tanks, or chimneys, etc. It has been used with the help of this. It has been made with the help of the steel structures. It is nothing. It is just an example for the old arch bridges, in which these are the steel structures. It has been made with the help of the steel structures. So this old that is bridge, it has been made with the help of the steel structures. The old arch bridge, it has been made with the help of the steel structures. Again, these are the framed buildings. These framed buildings, it has been made with the help of the steel structures. Here, these are the members which has been provided. This is a column. It has been provided, or it has been made with the help of steel. These are the beams. Again, these are the interconnected beams are also horizontal as in X direction and in Z directions also. So these are the various types of beams. It has been interconnected with each others, and these are the columns which has been made with the help of steels. Okay? So these are the framed building. Nowadays total buildings, it has been made with the help of steels. Okay? So these framed building, it has been constructed with the help of steel. Again, this is also a figure, or this is also an image of the framed buildings which has been made totally with the help of the steel. Okay? So these are the different steel members, in which horizontal as well as in X direction and Z directions, all the members, it has been made with the help of the steels. These are the industrial sheds or industrial buildings, or godowns. We can also have the godowns. We can call this as godowns also. So industrial buildings or godowns, or that is sheds used for food grains, sheds used for the cement storage, so or shed used for the railway, that is nothing but the railway scrap materials. So these are the industrial sheds. So these industrial sheds are made with the help of steels. These are the steel members. Okay? It has been totally this shed, industrial buildings or industrial shed, it has been made with the help of steel. Okay? So this is nothing but the steel structures. Again, it has been covered with a that is plate. Here it has been the top surface, it has been covered with the plate, and internal members, these are the columns and beams, it has been interconnected with the help of the steel structures. So this whole frame or this whole industrial building, it has been made up of steels. Okay? Along with this doors, along with this slab, all these members, it has been made with the help of the steel. So this industrial building, it has been made with the help of steel. Again, truss bridges. This is nothing but the bridges which has been used for transportation purpose. So it has been laid above this river. Here there is a river, so it has been laid above the river. It can be used for railways also. It can be used for transportation of vehicles also. This truss bridge, it has been again made with help of this steel. Okay? So this is nothing but the steel. Trusses are also there. These are the inclined members, in which the forces will be transferred in inclined way. Already you have solved the or you have calculated the forces in the truss in engineering mechanics also. In some members it has been compressive force, in some members it has been tensile force. So all these calculations, transfer of load from this top members to the bottom members. So some part it has been a compressive member, or some part it has been considered as the tension members. So all these truss members, it has been made with the help of the steel. Okay? So again, we will study in unit number 1 the truss members also, compression members, tension members, and some part of truss we will find out we will find out the sections regarding the truss. Okay? Which angle section, or which what will be the size of angle sections required for this truss bridges also. Okay? Again, there is an example of the steel structure, that is the truss bridge. Again, this suspension bridges is also made up of truss. Here, these columns and this horizontal beam is there. this horizontal, it has been interconnected with the steel structures, whereas these are the tendons or these are the strings provided here. But this whole frame, it has been made with help of the steel structures. Okay, this bottom horizontal beam, it has been made with help of steel structures that has been interconnected with each others. And this vertical, that is post, or the vertical columns or the vertical post, where it has been stretched, this cables, it has been stretched. So all these loads will be taken by these vertical members and will be transferred along with this horizontal also. So all these loads calculations, or all these horizontal as well as vertical member, it has been made with help of the steel structures. So suspension bridge is also an example of the steel structures. All these are the various examples of the steel structures, where in nowadays all these members, or all these structures, it has been made up of steel. Again, this cable stayed bridges, again this, it has been made up of steels, this horizontal member, and this vertical post, it is RCC, but this horizontal, it has been made with help of the steel. Okay, again these are the cables which has with help of these cables, it has been stretched, and these load calculations will be transferred to this horizontal members with help of these cables. Okay, again, what are the different advantages and disadvantages of steel? Because already in last lectures, I've in a short way, I've gone through the advantages and disadvantages, but in broad way, we will see what are the advantages and disadvantages of steel structures. Because every member will have some advantages, or every structures will have some advantages as well as disadvantages. Okay, RCC members is also having disadvantages and advantages, whereas these steel structures will also have the various types of advantages and disadvantages. Okay, so in advantages, we will see the high compressive and tensile strength per unit weight. Here steel structures is having a compressive as well as tensile strength, because both the compressive loads as well as tensile loads, or the compressive as well as the tensile strength, it has been taken care by the steel structures. Okay, normally in beams, in columns takes the compressive load, whereas the beams takes the tensile loads. But here in this steel structures, both in both cases, the both members, it has been made with help of the steel. Okay, so here therefore high compressive and tensile strength per unit weight, hence low that is construction weight, and saves space. Okay, here space requirement is also yes, because in RCC structures, space required for the columns, or space required for the walls, or space required for the beams, a little bit more space is required. But here in steel structures, less space is required, and the construction weight is also low, because steel structures, it is having a nominal weight is there, and it is more that is nothing but the highest, it is having a high compressive and tensile strength. Okay, again, what is point number two? Aesthetic view is also good, because you have already seen in previous slide the various structures which has been made with help of steel. So aesthetic view, in the sense, the external view and aesthetic view of the steel structures is a very because in any shape we can build the structures, in any shape and size we can build the structures. We can have the different aesthetic views also. The aesthetic views, it is been taken care in the steel structures. Okay, so good aesthetic views, it has been taken care in the steel structures. What is point number three? That is nothing but the good quality and durability. Is again the quality of the steel we are using for the constructions of various types of structures. So here quality of steel is also the quality, it is also maintained in the case of steel structures. And also the durability. Durability is nothing but the time span. Okay, for the time span, that is for 50 years, for 100 years, the strength of steel is also durable. For lifespan, for longer span, for longer span, the durabilities of steel is more. Again, fourth point is nothing but the very high speed of constructions. Again, the time required for the construction is less as compared to the RCC structures. The construction time, it has been the speedy construction can be taken care with the help of the steel structures. Okay, And reusabilities and scrap values, if after some years if we are demolishing the structures, so we can reuse the scrap materials. Okay, in steel structures we can reuse the beams, we can reuse the columns or the materials which has been used, and we can reuse the materials as a scrap materials, or we can sell that materials. Okay, and utilize that amount for some other construction works. Okay? So reusabilities and scrap value, that is environmental friendly is there, and better solutions to cover large span and tall structures. We can use the better solutions to cover large span and tall structures. So in tall structures also, and in large spans also, we can use these steel structures. Again, what are the different disadvantages of steel structures? So that is the initial at a higher the initial cost in the steel structures at a initial stage, it is high. Okay, the high cost at the initial stage, and also the steel structures, it is having a corrosion. It is nothing but the after some years, due to atmospheric actions, due to wear and tear, or due to atmospheric actions, so there may be corrosions. Okay, there may be wear and tear in the steel structures as compared to the RCC structure. There is more corrosion in the steel structures. Okay, corrosion, that is nothing but the wear and tear, or the decrease or decay in the materials. Okay, so decay in the materials, it has been taken care in the that is more in the steel structures. Again, low fire resistance. Again, in steel structures, you have already heard about the various types of structures. It easily catches fire because melting point of the steel structures is high. If it catches fire, so it is the deflection in the steel structures is more as compared to the RCC structures. So here it is having a low fire resistance. Okay, the steel structures, it is having a low fire resistance. Again, what is a steel? The steel making. In short, we will go through the various steps, how the steel, it has been manufactured in the companies, how what are the different steps followed in manufacturing of steel. So in short, we will go through the various steps covered in the manufacturing of steel. Okay? So steel making, first iron is extracted from iron ores like hematite, limestone, magnetite in furnace. Blast furnace, in blast furnace, this limestone, manganese, and hematite material, it has been extracted, and from this iron, it has been extracted. Okay? And again, oxygen is passed through the molten iron to remove carbon and impurities to make steel. Again, oxygen, it has been passed through this molten iron in order to remove carbon. Okay? In order to remove the carbon, and in order to remove the impurity, in order to have the impurities to make steel. Okay? Again, third point is nothing but manganese is added to strengthen the steel, in order to maintain the strength of steel, in order to increase the strength of steel. So manganese, it has been added in the steel. Okay? So manganese plays an important role in increasing the strength of steel. Okay? So this manganese, it has been added in order to increase the strength in the steel. Okay? So manganese is added to strengthen the steel. Adding chrome, nickel, and phosphorus can impart special properties in steel. Again, while other properties can be increased while adding with the help of nickel or phosphorus, or by increasing the different properties, these materials are also added. Again, semi-finished products from the machine is hot rolled. Again, while giving a special shape, the hot rolled steel sections with the help of different sections, it has been made up of different sections. That is bars that has been made, plates or angles or sections or different sections. It has been converted to this whole hot rolled steels. It has been converted to various sections. That is bar sections or plates or angles or different sections. Okay. Again, adding carbon increases the tensile strength and hardness, but lowers ductility and toughness. Okay, so little amount of carbon, it has been also added, which will result in tensile strength, but it hampers the hardness and it lowers the ductilities and toughness. Again, in buildings, we use structural steels which has low carbon of up to 0.1% to have ductility and yield. Okay? So in normally we are using the steel with a less carbon, about a 0.1%. We are using the steel which is having a carbon of least percentage of 0.1% in order to have the ductility and yield. What is ductility? It is nothing but the long span, that is strength of the steel. Okay? Durabilities of the steel. These are the various flow charts in the factories from first stage to last stage. These are the various chart related with the manufacturing of the steel. Here it is nothing but in top, it is nothing but the iron core, limestone, that is coal. It has been passed through this blast furnace. Again, after hitting open, that is hard. It has been passed through this oxygen steel process. Again, it has been poured. It has been converted into various plates. Again, it has been soaked into a proper tanks. That is blow mill is there, a breakdown of mill. Again, it has been converted to the various shapes. Okay, so here I sections shape or circular sections or any type of sections, it has been converted. Finally, it has been converted as per the requirements. Okay. What are the properties of steel? Again, these are the important concerns regarding the properties of steel. Okay, so what are the different properties of this steel? So it has been mentioned in IS 800 to 2007 clause number 2.2.4. So these are the clauses mentioned. That is clause number 2.2.4, that is IS 800 2.2.4. In this clause or in this IS code, the properties of the steel, it has been given. What is the density of steel? uh, Gamma is nothing but the density of steel. What is the density of steel? Normally, density of steel, it has been taken as 750 kgs per meter cube. In kilonewton, it has been taken as 78.5 kilonewton per meter cube. So here it is nothing but the density of steel. Normally, the density of steel, it has been taken as 750 kg per meter cube. What is the modulus of elasticity? E is nothing but the modulus of elasticity. So modulus of elasticity of steel, it has been considered as 2 into 10 to the power 5 Newton per mm square. 10 to the power 5. Okay, it is not 105. It is 10 to the power 5 Newton per mm square. Okay. So in 2 into 10 to the power 5 Newton per mm square is the modulus of elasticity of the steel. Again, what is Poisson's ratio mu? Poisson's ratio mu for this steel is nothing but the 0.3. So these are the basic, that is the properties of steel. That is nothing but the density of steel, modulus of elasticity of steel, and Poisson's ratio of the steel. What are the different properties again of the steel? What are the different things considered in the steel? So ductility is also important thing considered in the steel. So what is ductility? Ability of material to change its shape without fractures. Okay. So without fractures, the property of the material to change its shape. Okay. So without fractures, we can change the shape of the steel. Okay. To a circular sections, to a I sections or L sections or different T sections. So without fractures or without crack or without fractures, or we can convert this steel into different shapes. Okay, so mild steel, it is having a high ductilities, whereas high carbon steel, it is having a low ductilities to change to different shapes without fractures, without crack. Okay, so conversion of steel to various shapes without crack. This property is nothing but the ductility. So mild steel is it is having a high ductilities. Mild steel is having the high ductility, whereas high carbon steel, it is having the low ductilities. Okay, it is having a low ductilities. What about the toughness? So toughness and brittle fractures. What is toughness? Ability of materials to resist or to absorb impact load, like earthquake load or machine load or moving load or vibrations load. So this ability to that is resist or absorb impact load or moving or vibrations load or machine load or moving load. So these ability is nothing but the toughness. Okay, this ability is called as the toughness. Again, requires both strength and ductilities. It requires toughness, required both strength and ductility. At a lower temperature, steel fails on impact loadings due to reduction in ductility and toughness, called brittle fractures. Okay, what is brittle fractures? There is nothing but the breaking of steel at low temperatures. There at low temperature, there is a steel can be converted into a brittle stage. It can be converted into a pieces. Brittle is nothing but the pieces. Again, temperatures at high temperature, strength reduces. You have already seen when there is high temperature, there is the elongations is there, little bit there is elongation, change in shape of steel. So at high temperature, strength reduces. The strength of the steel gets reduced. Again, last point is nothing but the corrosion. Steel corrodes in moist air when the atmospheric in Mumbai cities or in seashore where the construction it has been made up of steel in seashores. So due to this seashore, the corrosion it has been taken care. Okay, so steel corrodes in moist that is air uh, and sea waters and acids, or adopt painting, metallic coating, plastic coating, using corrosion resistant steel to resist corrosions. So different coatings nowadays, the different that is the coatings it has been used in order to resist the corrosion, in order to avoid the corrosion. Different coatings it has been made. Okay, the plastic coating, metallic coating, in order to reduce the corrosions. Okay, what is the hardness? Hardness is nothing but the resistance of materials to intentions and scratching. Okay, so scratching is nothing but the intention to resistance to scratching, resistance to that is on the top surface of the steel structures. It has resistance to the scratching is nothing but the hardness. Again, Brinell hardness test, Rockwell hardness test numbers are used to measure the hardness. Already you have gone through these experiments. Okay? Rockwell hardness test in CT also, concrete technology also, Brinell hardness test. So all these test numbers are used to measure the hardness. Again, what is fatigue? Fatigue is nothing but the damage of materials to cyclic load when the cyclic load it has been taken care. So due to this cyclic load, there may be failure in the steel structures. So the such failure in the steel structure due to the cyclic load, due to the moving of cyclic load, is nothing but the fatigue. Again, it occurs due to moving loads, due to vibrations in the bridges. So it has been occurred due to the moving loads or vibrations in the bridges. Again, residual stress. What is this residual stress? Latent stress present in the steel sections due to uneven heatings and cooling during steel making. Okay? So due to uneven heatings, some part of the steel it has been heated and some part of the steel it has been in a cool stage. So this uneven heating will result in the residual stresses, because in some part stresses will be more and some part stresses will be less. Okay? So due to this uneven balancing of the temperature in the steel, this residual stresses or these stresses will be developed. Okay? Again, these stress concentrations under loadings, stress is concentrated at a place at abrupt change in the geometry, like holes, bolts. So here it's different stresses it has been generated, because in holes or where bolts it has been tightened, where rivets it has been tightened. So at that space, the at the holes where the bolts it has been tightened, the stresses it will be concentrated. The large amount of stresses will be concentrated at the point where bolts are it has been tightened. Okay, at the point where bolts it has been tightened. What are the different types of steel sections? What are the different types of steel sections? We have gone through the various properties of steel sections. Again, in IS code or in IS 800 2007 or in steel table. So in steel table there are the different steel sections. So we'll go through the different types of steel sections. Okay? So steel sections, steel is rolled to required a shape. During fabrications, what are the different shapes of the rolled steel sections that is commonly available? That is I sections. It has been in the shape of I. It has been mentioned in the shape of I. That is, it is also called as I sections. T sections. It has been in the shape of T. Channel section. It has been in the shape of C. Channel sections. Now, normally these channel sections or I sections, it has been used in the sleepers, railway sleepers. You have already seen the sleepers. So sleepers, it has been made up of this I sections. Sleepers of railway sleepers. Okay, railway sleepers is nothing but made up of this I sections. T section, normally beams. It has been made up of these T sections. Channel sections also beams. It has been made up of this channel sections. Again, angle sections. L is nothing but the angle sections. That means these vertical and horizontal part in this uneven angle section is also there. Even angle sections is also there. So L shape is nothing but the angle sections. Again, last is nothing but the steel bars, tubes, plates, sheets, and streets. Okay. These are the strips are these are the made up of the steel sections. So all these it has been made with the help of the steel sections. So here steel tables it has been used with all these sections. It has been mentioned in the steel tables. Steel tables. So you have to purchase or you have to download the steel that is the sections or steel tables from the Google's. That is the browser. You have to download the steel that is the tables also. Okay? IS 800 2007 also and steel tables also. So in steel table these are the various steel sections it has been used. There is I section, T section, C section, L section, and these are the tubes, plates, and sheets. These are the different sections where it has been taken care in the steel table. So these are the shapes of the various T sections. So this is the shape of T sections in which there is some curve part. It has been taken care. Okay, while constructing or while fabricating this, while manufacturing these steel sections, this curve part it has been made in order to take the stresses. Okay, to transfer the stresses or transfer the loads. Okay. So T sections, L section, HSS, there is high, there is standard sections, there is circular, there is tube sections, wide, there is I beam sections, this is I sections, I beam sections. But here this width is also there is wide. The wide flange sections is there. This is normally I sections, which is having the shape of I, and this is C sections. That is then nothing but the channel sections. So these are the various shapes of the steel sections. That is T, L, wide flange, and I beam sections and channel sections. Again, these are the some short forms used in the steel tables. So what are these nomenclatures or these short nomenclatures explains? So what is ISJB? What is this ISJB stands for? So Indian Standard Junior Beams. So in this short ISJB, it has been mentioned in the steel table. So you have to go through what these things actually means. So ISGB stands for Indian Standard Junior Beam. Indian Standard Junior Beam. What this ISLB stands for? Indian Standard. IS starting towards alphabet stands for Indian Standard, and last stands for the sections. Okay, depending upon the shape of the sections. So Indian Standard Light Beam. L stands for light beam. Again, Indian Standard Medium Beam. Light beam, medium beam, wide flange beam. W beam is nothing but wide flange beam. H stands for heavy beams. Indian Standard Heavy Beams. Okay. So M stands for medium beams. W stands for wide beams. L stands for light beams. H stands for heavy beams, and J stands for the junior beams. Okay. These are the shape of there is nothing but Indian Standard Medium Beam ISMB. 500 normally it has been mentioned in this way in steel table ISMB 500, and at its weight it has been mentioned that is 0.852 kilonewton per meter. This is nothing but the weight per unit length. What is the weight of this steel per meter? Per unit length. Per unit length is nothing but per meter. तो पर मीटर कितना वेट रहेगा उसका? तो 0.852 किलो न्यूटन पर मीटर. ठीक है, दिस इज नथिंग बट द वेट ऑफ दिस आई सेक्शंस. What about this? It has been mentioned in it has been written in this way: ISMB, Indian Standard Medium Beam, and it's 500. What this 500 indicates? This 500 indicates the depth. From this top to bottom is nothing but the depth. There is top flange is there, bottom flange is there. This thickness is nothing but the web. It is called as WEVB, web. Okay. So this TW is nothing but the thickness of web. BF is nothing but the width of flange, that is bottom flange, and width of top flange, and thickness of web flange, thickness of flange. Okay. TF is nothing but the thickness of flange. TW is nothing but the thickness of web. TF is nothing but thickness of flange, and BF width of flange, and here it is symmetrical eye sections. Okay. X direction and Y directions. These are the various steel sections in which horizontal I sections, and these are the in X and Z directions. Here I sections, there is columns is also made up of I sections. So all these are made up of these I sections. Okay, these beams, horizontal beams, that is in X direction and in Z directions, all it has been made with help of this I sections, and vertical columns is also made with help of this I sections. Okay, so here the shape of this I it has been made. Again, beam to column constructions or connections. Okay, here columns it has been connected with the beams. Okay, so here it has been floor slab. Here upside is also made, we can apply construct here also the floor slab. These are the interior columns. There is I sections, which is there is interior columns. It has been made with the help of I sections. Again, this exterior columns, this spandrel beams, that is in Z directions. It has been made of again with the help of I sections. There is floor girders, top floor girder I sections that has been made. Intermediate joist or floor beams it has been also made with the help of this I sections. Whereas there is a steel plate, there is floor slab, there is steel plates it has been used, which is having a some particular thickness. Okay. Again, rolled steel channel sections. We have seen beam sections, that is I sections, and here it is the channel section, that is C section. Indian standard light channel sections, Indian standard medium channel sections, Indian standard high heavy channel sections, Indian standard special sections. Okay? Channel sections, Indian standard special channel sections, Indian standard special channel sections. Okay? What is example of ISMC? That is Indian Standard Medium Channel Sections 300. And again, these two things already we have seen in I sections. What this 300 stands for depth, and what this 0.351 kilonewton per meter stands for the unit weight per meter length. Okay, this is width of top flange, width of bottom flange. This is thickness of web, vertical height, thickness of web, and this curved part is called as the fillet. In order to avoid the fracture or crack, and in order to decrease the strength of stresses, so this fillet it has been used. Okay, this fillet curve it has been used. Here also fillet is used. Here also fillet is used. So in this way, ISMC 300. Again, this is example of channel sections. Okay, well, these are the examples of channel sections. All these members it has been made with the help of channel sections. Intermediate beam set has been made with X and Y direction. It has been made with the channel sections. Vertical columns it has been made with the channel sections. So all these members it has been made with the help of the channel sections. Again, angle sections. What is rolled steel angle sections? So ISA, Indian Standard Angle, in which there are two types of angles: equal angle and unequal angle. This is unequal. Width is less and height is more. These two are unequal. These two are equal. So equal angle sections, so IS, Indian Standard A Standard Angle. And what about this size? So 150 by 150 by 12. What this 150 and 150 stands for? So 150 stands for this H, and this 150 stands for B, and this 12 stands for the thickness overall thickness on all sides. Okay, this 12 stands for the thickness overall from all sides. 150 vertical H, B 150, and 1, that is 12 is the thickness. Again, unequal, for unequal, it stands for 150, but this width is 115, that is less than 150. And what about the thickness? The thickness is 12 throughout, that is 12 angle sections. So all these are made with the help of this angle sections. This is the example of an angle sections. Okay? So again, there is a fillet here. Take a fillet here. The angle sections, these are the equal angle sections. These are the examples of equal angle sections. Okay? And this, there is tower, electrical tower. It has been made with the help of angle sections. It has been made with the help of the angle sections. Again, what is next? Ruled T sections. We have seen beam sections, we have seen channel sections, we have seen angle sections, and lastly it is T sections. Indian standard normal T sections, Indian standard heavy T sections, Indian standard, that is special legged T sections, light sections, T sections, light beams. So here it has been made in the form of T. Okay, here it is top width, width of the T sections, height of T sections, here fillet it has been provided, and here it is the flange. This is nothing but the flange. This is nothing but the flange. This vertical part is there. Other sections, that is steel bars are there. Indian standard round bars, RO stands for round bars and SQ stands for square bars. So steel bars is in the shape of round also, in the shape of square also. So in some cases we are using the round bars, and in some cases we are using the square bars. So Indian standard round bars and Indian standard square bars. Again, there is a steel tubes are made up of steel, and steel plates is also taken care of. Okay. Again, how to have a choice of sections, how to select the sections, how to decide the sections, particular sections. So it governed by the sectional properties and availabilities. So different properties by seeing the height or weight or load taking capacities, or modulus of elasticities, or Poisson's ratios, or that is nothing but the various that is the density of steel. So all with help of this all things, this will decide the section to be taken care. Okay, which section to be taken care. So all these will be decided with the help of the modulus of elasticity and the properties of the steel. Normally in India standard medium beam it has been used, and Indian standard medium channel sections and equal angle sections it has been used. Again, channels are used in purlins, T's and angles in trusses, I sections in beams and columns. Okay. Channels कहाँ पे use होता है? Channels that has been used in purlins, top part of this trusses. T and angles is used in trusses, whereas I sections that has been used in beams and columns. Other forms of sections, built up sections that has been used, stepped wide flange, hybrid sections that has been used, cold formed, that is the form from light gauges steel strips that has been used, which has been made up of the steel sections. So we will see one by one what are the different types of steel structures and where it has been used. This is just the section of a steel structure, section on the various components of steel structure. There is the shed, industrial shed. Okay. These are the bracings. Okay, bracings providers, rafters, which has been provided here. These are the purlins. This purling board it has also used this. These are the purlins which has been provided. This is nothing but the roof cladding which is also made up of steel. Steel jackets or roof jackets it has been made, and roof bracings. There is eaves gutter here for drain out the waters. That is the in case of rainy seasons to drain out the water which has been collected at the top. So here this eaves that is gutter it has been used. Again, these are various things it has been considered in case of this industrial sheds. Okay. What are the different types of loads considered in steel structures? What are the different types of loads considered in steel structures? Okay. So dead load, that is sulfate, and that is the purlin load. Okay, perm load. IS 875 part 1, it has been mentioned in IS 875 part 1. That is nothing but the dead load, and it has been taken care of sulfate and the purlin. Sorry, it is nothing but the purlin. Purlin. Live load is also there. Changes from time to time. Persons, furnitures, etc. Wind load is also considered. It has been taken care in part two. That is IS 875 part one, part two. In part two, live load it has been considered. Whereas in part three, IS 875 part three, wind load it has been considered, and IS 893 earthquake loads it has been considered. These are the different IS codes to be referred while calculating the dead load, live load, wind load, and while considering the earthquake load. So these are the codes given: IS 875 part 1 for dead load, part 2 for live load, part 3 for wind load, and 8 IS A1893 for earthquake loads. These are the design philosophy, that is working stress method. Stresses at which the material starts to yield is taken as the permissible stress at the sections. That is nothing but the working stress. What is the working stress? Permissible stress is nothing but the working stress which has been taken care in the various members All sections are designed not to exceed the permissible stress, not to exceed the permissible limit. Okay, the working stress method is, what is the working stress method? Within the permissible limit, we have to apply the loads. Okay, so we cannot increase the load. Okay, if the load it has been increased, the breaking of that steel, or fracture of steel, or crack in the steel will be taken care. So we have to apply the load within the limits, within the limit, the permissible limit. So such consideration will be considered in the working stress method. Okay, the permissible stress is nothing but the yield stress, and factor of FOS is nothing but the factor of safety. Since steel can resist load after yield point, following this principle results in bulky, uneconomical sections. So while considering this, the sections will be bulky sections and uneconomical sections. Okay. So therefore, this is nothing but the working stress method. What is the ultimate load method? The permissible load is a load when all the fiber in the steel is yield. When all the fibers in the steel, it has been up to the maximum limit, it has been yielded, or the plastic design up to the maximum limit, we can apply the load. So this such ultimate load is nothing but the maximum load. Okay, so up to maximum there is a load taking capacity of the steel, we can apply the load. Okay, this method is considered as the ultimate load. But here this working stress is permissible limit, but here ultimate is nothing but the maximum load. Okay, this method does not ensure serviceabilities. We cannot consider the serviceabilities in case of ultimate load method. This method is again important. This is the last study in this case. This in this IS 800 2007, or in this steel structure subject, we will consider the limit state method. We will not consider the working stress method, or we will not consider the ultimate stress. We will consider the limit state method. What is limit state method? It considers both strength and serviceabilities. Serviceability is long life. That is the durabilities. So we will consider the strength as well as serviceabilities by considering the maximum limit. We can apply the load up to a maximum limit throughout the lifespan. So in this strength and serviceability concept, it has been considered in the limit state method. Again, what is limit state of serviceabilities? Minimum deformations, deflection, cracks, vibrations, corrosion to ensure aesthetic views, and functionalities and safety to partitions. That means there will be minimum deflections, minimum damage, minimum cracks, minimum vibrations, minimum fractures, minimum all these will be considered minimum in the serviceabilities. That means the life of that structure will be increased. Life of that structure will be increased. Next is nothing but the limit state of strength. This structure should be stable and not collapse under loads. So limit state of strength, that means it will take the maximum load, and it will not collapse. It should take the maximum load without fractures, without that is collapse. Okay, so this will be considered in the strength. Again, this gamma F, that is nothing but a partial safety factor for load. It has been mentioned in IS 800 2007 table 4, and partial safety factor for the material, it has been mentioned in table 5. So all these will be considered in the steel structure. So these are the basics regarding the steel structures. Okay. So here in today's second lectures, we have seen the various properties of steel structures, sections of steel structures, what are the different nomenclatures used in the steel structures, what are the different things covered in the steel structures, or what are the different concerns regarding the steel structures. Also, in last slides, few slides, we have seen the methods. That is the working stress method, ultimate, that is plastic hinge method, and the and limit state method. So out of these three, we will consider the limit state method. Why? Because serviceability and strength. Okay. So here we will end the today's lectures. Okay. So here we will end the today's lectures. Thank you. Thank you. Today we will end here we will end this today's lectures. Okay. So here we will end this today's lectures. So if anyone having doubts related with the today's lectures, so they may comment to me, or they may ask me through the WhatsApp, or through the calls. You can ask the questions related with the doubts related with the steel structures also. Okay. So here we can end this today's lectures. Yes. Yes, we will end this today's lectures. Okay. So I'm leaving this today's lectures. Thank you. Thank you everyone.